everybody. We're still talking about hydrocarbons, and there's also some also known as tidbits I want to kind of talk about before we go on. So alkenes here are also known as olefins. So alkenes are also known as olefins. Ethene whoa, getting some interference there. Or AKA, also known as ethylene. So remember that as we start going into talking about polymeric structures. Polyolefins are probably the most commonly used category of polymers. We have an activity later on in the semester called Fun with Polyolefins. And before I moved forward, I wanted to kind of touch base on what we've already talked about. So we're still talking about hydrocarbons, and some of these groups interact with one another and end up having a profound effect on the mechanical properties of our polymers. And so that's something that I want you to kind of keep in mind. And I'm going to write it out in addition to saying it. But structure property relationship, I'm just going to write it now. Slash property. So there's a huge structure property relationship in polymers, and hopefully you can read this. It looks like, I don't know, I gave a crayon to my 2-year-old daughter when she was 2 or something, so sorry about that. But structure property relationship, extremely important. I touch a little bit on structure when I start talking about, these angles, and there's actually a 3-dimension to this methanol molecule, that kind of thing. The next kind of hydrocarbon we're going to talk about, and you have a supplemental video on this that I've assigned, are, I'm losing my own train of thought, man. Aromatics, goodness gracious. And there's a video I'm going to have you watch by someone who's much more charming than me. There's also some supplemental videos in that video series that you might want to take a look at should you find this lacking. And benzene is a pretty common example aromatic, I think. Anyway, is benzene. And benzene is C6H6, and benzene, I'm trying to say what I want to say about benzene, but benzene is our ring structure. And I'm going to write this, so benzene's a ring structure. I'm going to write it elsewhere on my little screen here. Right, so we have our benzene ring structure kind of at every inflection point. There's a hydrogen. And there's a carbon here at every point as well. And I kind of goofed it. There we go. So C6H6 benzene. Benzene is extremely important, and if we take a look, and I'll talk about this again, but aromatics start becoming really important in polymer structure because they strengthen polymers. It tends to strengthen polymers in a way. So I should probably change this to say it affects, excuse me. It greatly affects mechanical properties. The presence of benzene in a polymeric structure tends to mean it's pretty strong or has some sense of rigidity. And we'll talk about that a little bit now. I'm kind of digressing a little bit away from talking about organic compounds. However, it's pertinent. Where I said we're going to kind of mix up polymer structure and basic organic chemistry at kind of the same time. So if we look at the polyolefin, and then this is polyethylene. And I'm going to use this nomenclature. And hold on, man. I know you guys are thinking this should be a double-double carbon bond, but we're going to say it's polymerized. And so we'll use this notation to say it's polymerized. And so there's another chain here kind of satisfying the bond that this carbon needs to be happy, and another chain here, or another mer here satisfying this. So polyolefin, polyethylene is kind of the base polyolefin. So it's polyolefin. So we said that olefins are synonymous with alkenes. Ethylene is an alkene. It polymerizes. One of these bonds breaks. We'll talk about that a lot more in detail as the class goes on. If we look at polystyrene, we have the same olefinic structure, but instead of a hydrogen here, we have the benzene ring, if I can draw it. And so this benzene ring, this aromatic, this aromatic is known as a pendant molecule. And hopefully you guys don't hear my child in the background. So this pendant molecule is, I didn't draw it very well to scale, but this pendant molecule is much bigger than a single hydrogen atom. And what happens is it basically impedes the movement of chains, okay, of polymer chains. And I probably should draw this the same way. So this has now become kind of a big mess, I'm sorry. But there's a repeating structure. And again, we're kind of meshing polymer structure with basic organic chemistry. But I will come back to this again and talk about it in a lot greater detail. Polyethylene, polystyrene, both polyolefins. The difference in their structure is that instead of a hydrogen here, it has an aromatic benzene. So it has a benzene ring basically here. We've knocked off a hydrogen, so it bonds with the carbon. However, the ring is still there, still has its ring structure. changes the mechanical properties. So polystyrene, if you can envision it, if you have something made out of polystyrene, a CD jewel box, if you guys still buy CDs, compare it to a milk jug, go see which one's more rigid. The presence of this pendant molecule is what makes polystyrene more rigid. I digress just a tad. Also, all right, so we have our benzene ring and we have our aromatic pendant molecule. To allow it to combine with polystyrene, basically, we have what's called an arene. And an arene would have the chemical formula. So benzene itself is C6H6. Excuse me. C6H5 is an arene. So this chemical formula is C6H5. And it's characterized by alternating double and single carbon bonds. They move around. There's a lot that's not really known about that movement. So it's actually still kind of interesting. So arenes. So we talked about alcohols before. So I'm going to make a little jump back to alcohols. And alcohols, it's an oxygen-containing organic compound. And so we're going to kind of come and talk about another oxygen-containing organic compounds. So other oxygen-containing So we have some others. So we talked about arene. Arene, the abbreviation can be AR negative. So it's not argon, it's AR negative. A phenol is a arene attached to an alcohol, basically. And so if I draw my benzene ring and then put an OH on it, that's a phenol. So other oxygen-containing compounds, another common one is a glycol. It's also known as a diol, aka a diol. And let's look at ethylene glycol. As an example. I think I've done that. Another oxygen-containing organic compound would be an ether. An ether. And we can do that with our hydrocarbon. Messed up. Sorry about that. And this ether structure, you can replace the R with an ethyl group. So you can say ETOET. So this would be diethyl ether. Still on the subject of oxygen-containing compounds, one that plays a big role in polymers would be an epoxy. And an example epoxy is C2 C2H4O. This is ethylene oxide. And it has kind of an interesting structure. If you draw it out, and let's see if I can remember. Epoxy structures, it ends up being a thermoset polymer. Are basically based, some thermoset polymers anyway, are basically based on molecules of this structure. Another oxygen-containing compound is a peroxide. So peroxide would have the ROOR, or hydrocarbon, oxygen, hydrocarbon kind of structure. A example is a benzoyl peroxide. And benzoyl peroxide, I bring that up because it's an important cross-linker. And when we talk about polymerization and polymer structure and polymer processes, this terminology becomes a, I guess, almost secondhand. But it has an interesting chemistry, a lot of carbons. I can kind of draw the structure of benzoyl peroxide. It's going to draw it like that. It's kind of a double bond with this oxygen. All right, so this is benzoyl peroxide. We have two arenes, basically. And so if we look up here, and I'll go into this in more detail when we talk about polymerization and stuff like that. But if we look at the example of polystyrene where we had this arene ring, you can basically use the arene on either side of the benzyl peroxide molecule to link two polymer chains of polystyrene. So that's how that functions as a crosslinker. I'm going to, I think, end this here, and then we'll pick up some other compounds in the next lecture.
Oh my. It's the end of the lecture. If you have any questions, you can email me at drobertson@utep.edu.